Good morning, creators, and welcome to another UEFN tutorial. In this episode, I'm exposing the secret behind raycasting, which is the tool that devs use to detect collisions in UEFN. The first type of collision we're going to discuss is the proximity collision, where when an object gets within the sphere, it detects that location. And the second type that we'll discuss is the linear collision, which is a typical kind that you're going to use in your mechanics. In case you missed it, I just released a secret on how to access the real time and date in Verse. And if you're interested in that, it's linked in this card or in the description below. But the first step for this tutorial is you're going to create a control rig, which is what we're going to use to access collisions. So you're going to right click in your content browser, go to animation, control rig, and create a control rig. We do not need a parent rig, we're just going to create blank. And we're going to call this first one proximity rig. You double click to open it up. So our first step, we're going to create a control which we're going to use to access transforms. This is going to be called, we'll call it proximity control, like that. And we're going to drag it out. We're going to get it. We're going to drag it out again, and we're going to set it. All right. So in here, I'm going to set initial on. That way it gets the initial transform of the control rather than the current one, just to avoid any confusion. And the node that we're going to use to access collision in this video is called sphere trace by trace channel. We're going to pull that out. And we're going to put the start here from our translation. And we are going to set the, we're going to use the hit event, which is a Boolean. We're going to tie that into an if. And this if condition we're going to use to detect if there's something within the volume. So by default, I want to just have an indicator that something is within. So just like a indication that something hits. So I'm just going to pull this here so I can change this to vectors, pull it out. If it's true, we're going to set the value to 2. If it's false, we're going to set it to 1. And we're going to set this into our scale 3D, which means if there's a collision that occurs, that means our scale is going to be set to 2. Otherwise, it's going to be 1 by default. Now to connect this, you just go from the forward solve into the execute contents, compile, and that's that. Next, you want to access the control rig in your map. And the way we're going to do that is by creating a blueprint. So we're going to call this just a building prop, and we'll call this the proximity prop. All right, double click to open it up. We're going to add a control rig component, and we're going to select our proximity rig here. And that is all we need to do for this. We're going to pull it out. Just place it like right here. And then in our details, that's where we're going to define what is going to be our prop to detect collisions. So I'm going to actually create a quick basic prop so that I can just look at it. We'll call this the empty prop because it really serves no purpose other than to read into Verse. I'm going to have editor only static mesh component. We'll make this a sphere real quick. It's important that this is the editor only static mesh component or something that doesn't have collision, because if it has collision, it will collide with our rig. That's one of the tricks of this is collisions will always affect the rig. So if there's anything within the area that has collisions on, it will affect the rig. So you need to disable collisions on anything, any projectiles or anything that you don't want to affect. All right, so go into user defined elements. We're going to go ahead and place down our empty prop like so. Go back to our proximity prop. In our control rig, our component reference is going to be our prop we just placed down. And we are going to output using our control we made here, which is called the proximity control. Proximity control, like so, and set the element type to control. and you'll see that it actually moves it to where it needs to be. So you'll see initially our scale is 1 because it's false. There's nothing colliding with this area. But if I were to pull out a shape, say a cube, and if I moved it closer, just a little bit closer until it collides, you'll see it collided there. It's within this radius. So it just scaled our prop. So you can change the radius of this collision sphere pretty simply. Just open up here, and you're going to set the radius right here. Let's make it 512, which is 2 tiles in diameter. And you'll see that it is colliding with a lot right now. So we're going to grab our proximity prop, move it up, and move things away from it. So you'll see once this gets within a tile, it will take that collision. Now, in our rig, we're going to create a control for this so that we can just define our value. And so we're going to call this the radius control. Pull it out. We're going to get control. And we're just going to get the scale Z and put it into radius like that. Compile. And move our proximity prop so that it updates. And so now, instead of a controller rig, we're going to create an input. And this input is going to be an input, of course. You're going to set it to radius control and element type control. Our offset right here is going to be the amount of distance or the radius of this sphere. So 256 will be 1 tile in diameter. And you can just dynamically change that inverse. If you want to, you can even hook this up to a prop to where the prop controls the input. And the way you do that, if I can reselect my proximity prop, is through the component reference. If you have a prop reference as your actor, changing the scale Z of that prop will change the scale of the radius here. Finally, I want a little radius to display where this collision box is going to be, or this collision sphere is going to be, because it's kind of hard to tell without it. So what I'm going to do is open up this. I'm going to pull out the Z, and we're going to make a vector and put that into our X, Y, and Z. Then we're going to scale this vector by a factor of 0.02, like so. And we're going to create an additional control, which we'll use to affect our objects. We'll call this a visual control. And we'll set that here. So we will set control. And in our value, we're going to put our scalar here. And then we will execute content. And then I'm going to place down a prop that I make, which is going to be called visual control, or visual prop. It's probably a better name. All right. And here we are going to have a spherical editor only mesh and a grid material, which I created. And then we're going to place that down. And of course, in our proximity prop blueprints, we're going to add a user defined element, which is going to reference our prop, visual prop, and output on the visual control, like so. All right, so now you'll see that it will collide and it shows the correct radius. Now, if you want to show the location it collides, it's pretty simple. Just pull the hit location into translation for our proximity control. And I gotta update this. So proximity prop, move it once. You'll see that it actually moves to the location where it. And now a quick word from the sponsor of this video, this raycasting tutorial. Alright, so now we have the linear raycast, which is probably the one that you're gonna be using more. That is going to be same process, control rig, nothing, and we're gonna call this the linear rig. Double click to open it up. We're gonna create a control, which we'll call it the ray control. Going to get, we're going to set, and we're going to use the sphere trace by trace channel. Alright, so we're going to make this initial, and then we're going to set the translation at the start. And at the end here, Z is all we care about. That's going to be the basically forward, or it's going to be up position from our control. Or you can use X or Y, doesn't matter. I prefer Z for whatever reason. I just like the up channel. So 100. We'll start off with, actually, let's do 512 times 4, 2048. Nice. And we're going to set the hit location to our translation. And similar to the previous demonstration, I want a way to make sure that I know that it has collided. So I'm going to get this hit event tied to an if statement. I just want this to be vectors, so I'll do that. And if true, we're going to make that 2. And if false, we want that to be 1. And we're going to set that into scale 3D. We can compile. And that's our initial ray tracing rig. You can change the radius of the sphere that's tracing through, or you can change the endpoints. It's up to you. But that's initially what we need. So I'm going to pull out, I'm going to make a Uber class. We'll call this the linear prop. Same thing. We're going to add a control rig. Select the linear rig. And once again, you're done. Then you can drop it into your map. And finally, tie a prop or shape or whatever you want to it. Actually, we have an empty prop, so let's use that. Yeah. So linear prop, go to control rig, add a user-defined element. Component reference is going to be our prop here. It's going to be output, control, and we're going to use ray control as our outputs. You'll see initially it's going to be at the center here, and it's going to be default scale because it's not colliding with anything. Now if I rotate this, remember that's up initially. If I rotate it, you'll see now it's colliding. And it increased in size to indicate that it collided with something. So now it's constantly updating. Now it's important, and I don't remember if I stated this or not, that for all of your meshes, that the mesh that you're using to track collisions does not have collision on. Otherwise, it will be the mesh that it's detecting collisions for. And also that it's set to movable, so that means it updates during the game. If it's set to any of these other ones, it's not going to update during the game, so the rig's not going to work at all. So make sure that's movable, and you should be all good to go. So now let's say that I don't like how when it's not colliding with something that it just reverts back to its origin. Well, you can create a fix for that where it's just always extended. And the way I'm going to do that is take my translation here, and we're going to add, and we're going to add the same variable we have here. That's going to be 2048. And so this is the vector whenever there is not a collision. So we're going to use our hit events here, if. So if it's not collided, we want to apply this basic one. So false. If it is collided, then we're going to hit the, not the normal, the location, like that. And then we can put that into translation. Compile, save. So you'll see it's always extended 2048. Even when it is not colliding with anything. So that's pretty useful. Now I'd like to make my rigs highly configurable so that you can create a variety of different kinds of rigs using the same blueprint. And the way I'm going to do that is adding a additional control. We're going to call this the config control. And so we're going to get this control, and we're going to use various scalar elements to determine what goes on. Let's say that the z here is going to be our spherical radius. All right. We're going to say this y is our radius for the, z was the distance, sorry. Y is the radius for the sphere that's detecting collisions. And then our x is going to be used to turn off the always extend thing I just created. So we're going to use a greater or equal to functions. In fact, we could just use greater than, I think would work probably a little bit better. Greater than. So if it is greater than 1, by default it's 1, by the way. If it's greater than 1, we're going to toggle off our if here. So if greater than 1, we're just going to use the default setting and plug that into translation. And that's about it. So of course in our linear prop we want to control that config control. So go to your control rig, we're going to add another user defined element. We don't need a component reference, we just need our control. We need to set it to input, and then we're going to say config control, like so. And so you'll see the z scale affects the distance it casts. And right now it's set to always extend. Yeah, it's set to very, very far distance. We'll just do 512. All right. But I don't want to always extend, so we're going to say that like 0.9. Or 1.1? Yeah. So when it's greater than 1, it's going to not always extend. And you can also change the radius of the collision if you want, which is the y. Of course, you could change the distance here. And you'll notice that like there's a little bit of a weird glitchy thing whenever I'm moving it in the editor. But I promise you, and I've tested this in game, it doesn't show that glitch. Actually, it's not showing it, but it did show it when I was doing the testing for this video. So if you do experience that, it's not how it works in game. So you're good. That's pretty much it. That is pretty much the entire video. And I could demonstrate in game, but I mean, you already see it in the editor, so there's no point. Well, if you found this tutorial helpful, please consider subscribing, leaving a comment down below if you want to see any more videos regarding control rig, how to use raycasting, collisions. There's a lot of things to explore here, so if you have any ideas, post it below. If you have any creations you make from this tutorial, please tag me on Twitter when you post them. I'd like to see them all. And I hope you have a great day and good luck creating. And now a quick word from the sponsor of this raycasting tutorial, Rage!